In this video, we'll examine the graphs of the trigonometric functions, that is, the sine, cosine and tangent functions. We'll discuss amplitude and period and the phase of these functions. Here we have the unit circle, which is a circle of radius 1. We've got a point on the circumference of the circle with coordinates x and y, and that point makes an angle of theta with a positive x-axis. Now, looking at that angle theta, we define the sine of the angle theta as the y value of that point, and the cosine value is the x coordinate of that point. The y coordinate on the unit circle will give us the sine of the angle. At the angle there of 0, we'll have sine 0 is 0. As our angle increases, our length of y increases all the way through until we get to 90 degrees, which is our maximum value for y, which is 1. As we increase our angle beyond 90 degrees to 180 degrees, our y values are decreasing until we get back to 0 again. Going beyond 180 degrees, we have negative values of y now, and they'll keep increasing in magnitude until we get to minus 1 at 270 degrees, and then they'll start reducing in magnitude until we get back to 0 again. And the whole process is repeated beyond 360 degrees, and you can see that the period of that graph is 360 degrees. The cosine of an angle is the x-coordinate on the unit circle. So at 0 degrees, the x-coordinate there is 1. And as the angle increases, the x-coordinate is decreasing all the way through until we get to 90 degrees, where the x-coordinate there is 0. We increase the angle beyond 90 degrees, and now x is negative, and it keeps increasing in magnitude until we get to negative 1 at 180 degrees. And so the cosine of 180 degrees is negative 1. Increasing the angle beyond 180 degrees, x is still negative, and we're getting closer and closer to x being 0. And then we increase the angle further until we get back to the 0.10 where we started. We can then keep going, and you can see that we're repeating the whole process all over again. And once again, we can see that the period of this function is 360 degrees. So we've seen that the graphs of sine and cosine are periodic functions with a period of 2 pi and an amplitude of 1. The sine graph there starts at 0, and the cosine graph starts at 1. Now the graph of y equals a sine n x minus b plus c is simply a transformation of the graph of y equals sine x. We have a dilation of a factor a in the y direction. We have a dilation of a factor 1 on n in the x direction. We have a translation of c units upwards, and we have a translation of b units to the right. The amplitude of the new function there is a, and the period is 2 pi over n. We'll use the idea of transformations to graph this graph. Starting off with our base function of y equals sine x, we'll have a dilation of a factor of 2 caused by this 2 in front of the sine x there, which means that we have to stretch the graph by a factor of 2 in the y direction. We have a dilation of a factor of a half because of that 2 in front of the x. That means all the x values now have to be halved. We have a translation of 3 upwards because of the plus 3 there, so the whole graph moves up 3. And we have a translation here of pi onto the plus there means, of course, that it's going to go to the left. So we move the graph pi and 2 to the left. And that's our new function. Let's use the idea of transformation now to sketch this graph. We'll note firstly that the amplitude of this graph is 3 and the period is 2 pi divided by 2. So we'll sketch the graph of y equals sine x firstly. We'll stretch that by a factor of 3 in the y direction. And the minus 3 means that we flip that over the x-axis there. We now do a dilation of a factor of 1/2 in the x direction. And then we need to move that pi on 4 to the right to get our new graph. And that gives us the required graph. The trig function is defined along the tangent line to the circle there. The length there shown in green is the tangent of the angle theta. The tan of the function is defined as the length of the tangent line seen there in blue on the left-hand diagram. It is being plotted against the angle, and you can see that the period of this function is pi. So this is the tan function here. We'll note that the period of the function is pi, and that the tan function is undefined at x equals pi on 2, 3 pi on 2, and negative 3 pi on 2, and pi on 2, etc. We've seen how the trig functions are defined on the unit circle, and that the graphs or the functions of y equals sine x and cosine x have a period of 2 pi and an amplitude of 1. And we can obtain the graph of y equals a sine n times x minus b plus c as a transformation of the graph of y equals sine x. We've seen that tan x has a period of pi, and that doesn't make any sense to talk about the amplitude of that function.